In this video, we're going to work a fourth integration problem for product of inertia. The previous examples we worked were pretty easy, and they were pretty easy to convert or to express x in terms of y or y in terms of x, so that it let you easily choose different kinds of elements. This particular problem uses a more complex function for one of the boundaries of the area, and so you're more limited in what you can define in terms of dA. And secondly, trying to expand it out is way too much algebra that you want to do either on a homework and certainly on an exam. And this particular problem actually came from an exam, so you're basically forced to integrate on a calculator. So again, I strongly urge you to learn how to integrate on some type of integration capable calculator, like a TI-89 or a TI Inspire or some other calculator. And this example will illustrate that. Part of this document we're talking through also has some test questions on it. So let's talk about these test questions too while we're here. And so here's a question. A general shape has an area of 20 inches squared, has a moment of inertia of 106.7 inches to the fourth with respect to the x-axis. So that's its ix. The centroid is located 2 inches above the x-axis. What is the moment of inertia with respect to a centroidal axis? So this is an ix problem. It requires using the parallel axis theorem. So you write ix is equal to I bar plus AD squared. But it asks for I bar about the centroidal axis. So I bar is equal to ix minus ay squared. So the ix was given as 106.7 minus the area, which is 20 inches squared. And it's 2 inches from the axis to the centroid. So it's 2 squared. And so I bar is 26.7 inches to the fourth. Another example, it shows 3 shapes. Each shape has the same outline and the same hole, but the hole is located in a different location. It asks which area has the largest moment of inertia about the x-axis. And so A would be the largest because more of its area is farther from the x-axis. C would be the least because more of its area is closer to the x-axis. And B, of course, would be in the middle. So A is the larger. This is a conceptual question for product of inertia. It says when using the parallel axis theorem to determine the product of inertia for an area about a set of non-centroidal axes like xy. The second term on the right-hand side of the equation is area times the distances between the xy origin and the x prime, y prime origin. And so that's the proper answer. A is not correct. The C is not necessarily true. D is not necessarily true, and E is not necessarily true. The terms can be positive, or they can be negative, or they can be zero, either way. Okay, so here's a function. This was actually on a test at some point. So we have a function here defined by y squared is equal to 1 minus 0.5x. The y distance is 1 meter. The x distance is 2. We're asked to find the product of inertia with respect to the x and y axes. And so it's easiest to just use a double integral and use your calculator. And so it's equal to xy dy dx. And we just take y from 0 to the square root of 1 minus 0.5x. And x from 0 to 2. Plug that into your calculator, and you get ixy is equal to 1/3 meters to the fourth. just easier to do it on your calculator. This is actually another test question that we used for something similar to this a number of years ago. And again, because it's a little bit more of a complex function, it's harder to try to do it by hand or to do it any other way. So basically, you've got this area defined by this upper function is y is equal to negative x squared plus 2x plus 3. It's a trinomial. The 3 is at the y-axis where it intersects the y-axis. And the range on x is 0 to 2 inches. And we want to find ix, y for this area. So we can use a double integral, or we can use a vertical integral, a vertical element. We cannot use a horizontal element because it's just the way this is shaped. So a horizontal is not available to us. If we use a single integral, then we take a vertical dA, and the dA is dx wide. The height of it is a y, which is negative x squared plus 2x plus 3. X is x, and y tilde is equal to y over 2. So if you set this up as a single integral, we're going to integrate on x from 0 to 2. Our x tilde is x. Our y tilde is this function divided by 2. And then our dA is this function times dx. So we can set this up, but it's extremely painful to expand this out other than using a calculator to do it. So you're pretty much forced to use a calculator for this particular problem. And again, I think this was on a test. So you need to learn to integrate on your calculator. So you can actually just put this directly into your calculator as is. And so like on the 89, this would be like the integral of 0.5 times x times this function squared. And we evaluate that guy on x from 0 to 2. And you get ixy as 13.5 inches to the fourth. On the other hand, you can use a double integral. And we just use an xy element. I'm sorry, a dy dx element. And x tilde is x, y tilde is y. When we integrate y from 0 to negative x squared plus 2x plus 3, and x from 0 to 2, you can plug that into your calculator just as it is given. So as a double integral, x times y, y from 0 to our function, close the parent, and then x from 0 to 2. And you get ixy is 13.5 inches to the fourth. So again, just a harder function to deal with, and just take advantage of your calculator. You be sure to learn how to use your calculator to do these. Here's one more example that I had in this document. And again, this is an area between two lines. The top line is a straight line, which is y is equal to 3x plus 8. The bottom line is y is equal to 2x squared minus x plus 3. They intersect at x equal to negative 0.871 and positive 2.871. And our units are millimeters. And I just chose to integrate this guy between using a double integral. And so, but the integrand here is x times y, dy dx. I'm integrating y from 2x squared minus x plus 3 to 3x plus 8. And I'm integrating x from negative 0.871 to 2.871. And I get ixy. I can plug that into my calculator, double integral. Xy is the integrand, y from this function to this function, close the parent, x from negative 0.871 to 2.871, and I get ixy is 179.9 millimeters to the fourth. So again, just learn to use your calculator. It's a valuable tool. Choose a DA, work with it. And these are all just examples of integrating for product of inertia. The good news for product of inertia is that it's always pretty much the same setup, x tilde y tilde times dA. You can use any dA, a dx dy, dy dx, a vertical dA, a horizontal dA, and then just correctly identify or correctly model your x tilde and your y tilde.